All right, guys, in this video, I scored a compressor, a really nice compressor. The problem is that it was a 5-horse, 3-phase unit. And behind me, or my other compressor, my old compressor, is also a 5-horse unit. So I decided to convert this compressor to a single-phase 7.5 horse and get more CFM. And then I would have 2 compressors, right? And I was also moving. So I figured I'll talk a little bit about what I decided to do at the end of the video. For now, we're just going to convert a 5-horse 3-phase to a single-phase 7.5 horse. So enjoy the video, and in the end, I'm going to talk about what I ended up doing in this new garage. All right, so I scored another compressor, okay? I got a sweet deal on this thing, and I'll talk about the deal in a second here, but what we're gonna do in this video, there's a problem with this thing, and it's a 5-horsepower 3-phase unit. So 3-phase does me no good because I am residential and it's single phase. And I also have a compressor with similar specs, so there's no point of, you know, building this thing all up to have the same CFM. So what I'm gonna do is convert this to a 7.5 horse single phase unit. So this model, and most compressors have, you know, a pump like this, and they either run it at 5 horse or 7.5 horse. The difference being with 7.5 horse, you just basically spin it at a higher pump RPM to get more CFM. So my current compressor is 5 horse, this thing's 5 horse, and that nets you 17, 18, 19 CFM. Well, if I spin this thing a little faster in 7.5 horsepower mode, I can get 23 CFM or something like that. So, hey man, I want more air, okay? And this is a newer unit, so it makes sense for me to just upgrade it. Okay, so how did I score this? I paid $102.50 for this compressor, and it just so happened that the guy was coming this way, the seller, and he's like, yeah, I'll deliver it for 40 bucks. So bam, $145, and I have this compressor. Now, compressor prices have skyrocketed. This guy in 7.5 horsepower configuration is up to $3,900. That is crazy. So scoring this for $140, yes, I'm gonna have to put some money into it to get it to work in single phase and for my horsepower needs, but I will be well under that amount, So here's how I scored it. I've had an eBay alert. I get an email alert for the following criteria: air compressor, 7.5 horsepower, used, and X amount of miles from my zip code. So I set up that alert, and I just simply get emailed when new listings come about. Okay, and I've had this for 7 years or so, and up until now, it's been junk emails, meaning like I wouldn't even consider bidding on it. You know, these people want $2,000, $3,000, whatever. I'm talking, I want to score something much less, and something that'll... Anyway, so this email came out. This bid, or this thing was 20, 30 miles from me, half an hour away or whatever, and it started at 99 cents, no reserve, and it had a buy it now at 500. The problem was, if you look at the user that was selling it, 0 feedback. That means it was a brand new eBay person, and that isn't the best situation because, you know, you want someone with good feedback score, right? So anyway, I asked for questions. They listed it as a single phase unit. I'm like, all right, 5-horse single phase, sweet, you know. Well, that turned out not to be the case. I got it home, I looked at it, I'm like, oh, well, it's a 3-phase. Still not a deal breaker because I don't want 5-horse, I want more. Anyway, for $140, any one of these 3 components here, the tank, the pump, or the motor, is worth $140 alone. Anyway, so I sniped it. You know, it was bidding around a couple bucks, and at the last second, I put in my snipe bid, and it just went up to $102.50. Fine. So another thing is they deliver it, and I'm like, all right, thanks, here's your $140. And he's like, what? What did I put it up for 500? I'm like, dude, you put it without a reserve. And he's like, oh man. So the guy goofed, and he looked a little upset about it. And I'm like, you know what? If, you know, I get it. You can take it back. I don't care, man. He's like, oh, no, it's fine, whatever. They got it for free. They were contractors that were cleaning out a Home Depot, so this thing came from a Home Depot, and I think Home Depot was going to scrap it, and they're like, oh, no, we'll take it. You know, they were going to sell it and make a few bucks on it. Anyway, so this thing's from 2016. The tank tag is 2016, so that means it's only, 6 years old, which is awesome because mine is a 1987 date code. Yes, I replaced the pump. Yeah, it works perfectly fine, but it's nice to step up to a nice newer tank. And the oil looks clean. The air filter looks clean. I haven't rolled it over. The only thing that, they laid it down and they tweaked the back cover here. But it does come with an aftercooler and everything. So this is going to be a really nice unit. And this is a Champion brand, which is weird because, okay, Gardner Denver owns Champion, and this is Gardner Denver colors, this light gray. Champion are usually gray, so it's kind of weird how this is the wrong color and it's tagged this. I never seen that. But anyway, like I said, if I were to want this in 7.5 horse mode, brand new, $3,800 without tax and freight, okay? So what's nice about these is these pumps have been in production for a very long time. It's assembled in the USA. There's actually a compressor shop not far from here that stocks anything I need for this in stock. The documentation is awesome on this, so rebuilding it, getting parts is a non-issue. These are excellent pumps and so forth. So that's it. Let's start taking it apart. What's going to be needed is, I already got a new motor. We're going to need a new mag starter for higher amperage and single phase, and then we're probably going to do belts and pulleys, change the oil, change the filter, and bam, put it to use. It'll be a nice unit for vapor blasting to increase. So that means I can go from my 5 horse gun to my 7.5 horse gun and run that all the time, zero issues, and have plenty of air. Yep, super excited about that. So let's just get started here. Okay, super simple to take the motor off. I don't know if I mentioned this or not, but one thing, they laid it down on a pallet. So what happened is this bracket here, you can see, I think should be straight. No big deal, I can bend that. But basically, yeah, it goes like this. So you can see that the belt guard got tweaked. And that belt guard is that design is pretty crappy with that wire mesh stuff. But anyway, here's the big thing. Does it run true? Is the crank bent, right? That's a concern, right? So which way does this rotate? This way. Okay, so let's just roll it over. Okay, the crank is straight and also air is popping out of here. So far so good, and now it's just a matter of throwing the new motor on here. Alright guys, so here's a single phase 7.5 horse motor that I also scored. This is a Leeson brand, so a very good brand. It's up there on par with Baldor. But man, I tell you, it's even hard to buy an electric motor right now. It's crazy. A lot of these are out of stock. Anyway, I bought this used. Well, it's brand new, never used. The guy wanted to build a compressor himself. But anyway, never used. I got it for $600. If you wanted to buy this new, anywhere from $850 to $1,000, people are selling these. But look how freaking big this is, man. This thing weighs 100 pounds, over 100 pounds. This one here I was able to lift off. It's like 60 pounds. Just to give you reference, this is about 8 inches in diameter. This guy here, 10 inches in diameter. It's freaking a monster, man. So, but let's get this. I'm gonna need the hoist to get this into position. There's no way I'm gonna freaking lift this by myself. So let me get the unit cleaned up, and then we'll go ahead and throw this on there. All right, so new motor is in place, and what's nice is this base plate here has several different slots and hole patterns. Again, because this model is used for both the 5 and the 7.5 horse unit. The 5 horse was a 184T frame. This is a 215T frame. So it's a different size motor. Obviously, it's freaking huge. So what I did is, if you go online and just type in NEMA frame dimensions, they give you everything you need. So this 215T is kind of standard for 7.5 horse. So it comes with all these dimensions, and I was able to verify that this motor and this base plate would work together, and it works just fine. Also, I threw the bell cover on. You know, it needs to come up 1/2 inch and get bolted there, but basically this belt cover works for this larger motor as well. So again, everything's universal. It's just how they build these compressors up. So what I'm going to do now is I need to order a pulley, get the pulley on there, and then size new belts. So I haven't ordered that yet. I wanted to get to this point first, and then go from there. So what we can do is pull the mag starter off now and continue. Okay, so I had to buy a new mag starter. I'll explain what this thing does, and it was missing the cover. So I went with an Eaton brand. They're, probably the best option here. But basically, what this thing does is the pressure switch can't handle the current of the motor. So the pressure switch triggers this contactor coil, low amperage to feed high amperage through here. Okay, so this here is a 30 amp contactor for the 5 horse motor. Well, for the 7.5 horse motor, we need a 40 amp. And then we also need this guy here, which is a thermal overload. They call it a heater, a starter. No, it's a heater or thermal overload. So there's something in here that allows it to sense how much current and whatnot is going to the motor. And if it ever exceeds it, it trips it. Okay. So this guy here is, again, I believe it's 40 amp. This one, I guess it's 30 amp or whatever. So anyway, this was a $200 thing. Now, they market it as single and 3-phase, but if you look at documentation, the difference between the part numbers, the only difference is this jumper. See, this jumper comes out of, this would be the third leg. For 3-phase, it would go here, but to convert it to single phase, it goes out here and back up to here. So for single phase, you got 2 hots, right? And then for 3-phase, you would use all 3 hots. 3 hots coming in. Here you just have 2. So this jumper is the only thing. So this guy can be converted to single phase by getting a proper jumper coming here. So I'll be able to resell this, hopefully. I don't know. Or maybe I'll just pitch it in the garbage. Either way, that's that. So we'll go ahead and mount this up. Okay, let's talk about wiring here. My compressor obviously has a pressure switch, and it also has a low oil switch, which is these two red wires here. Okay, when there is oil in the motor, there's continuity between these two leads. Okay, and that is going to replace these two red wires. So basically, you have the pressure switch energizing one leg of the coil, and then you have this guy here energizing the other leg of the coil. And if either interrupts the circuit, meaning if the pressure is satisfied, it'll stop. It'll de-energize the coil. Or if it starts to pull too much current and the thermal overload here cuts it out, it'll de-energize the coil and it'll stop running. Okay, so those two items do it. So I got a third item here, which is the low oil switch. Okay, so now let's take this apart. And so basically I just need to replace one of these. I think I'll just replace this right here. Okay, we'll just pull this off. Jesus. God damn. All right. So now, okay, let's do the pressure switch first. That's easy. So what you're going to do, this is one of the hots. Okay, so what we're going to do is we're going to connect here first. Okay. Okay, hot in, hot goes, and off to the pressure switch, which you can't see. Jeez, I can't talk. All right, so and then this guy here, once the switch is closed, the pressure switch is closed, it's going to go back here and give power to the A1 side of the coil back here. Okay, so see how that works? Power to the switch, power back. Okay, so that's all hooked up there. Okay, so now we need to remove one of these legs and hook up the low oil switch. Okay, and then obviously wire the whip to this guy here. But yeah. Okay, so now we need to tie in the low oil switch. Okay, so all we got to do is remove one of these wires and tie that in, so it's basically an additional switch that can open and close and for safety. So we're gonna go with this one here because that's what it was on the old unit. So 96 and to the power here. So we're just adding another switch to the system, another safety, if you will. So this guy here is gonna get power from here. Okay, so that's that. And then here it's gonna go under and go to the 96. Where is it? Oh man, this wire's so tiny. Okay, so that's all wired up. The only thing we need to do is power in, one hot, two hot. So two hots in under these big lugs, okay? And then, you know, power will feed out. And then there's T1 and T3, two hots out to the motor. And then we got our ground, and that's it. Let's just verify something real quick here with the meter, okay? So we have power in, right? Let me just follow the electrical current. Right now it should run if power was applied because the tank is empty, so the pressure switch should be closed, and also the oil is full, so the oil pressure, the oil level sensor should be closed as well. A closed switch means continuity. So power in's here, right? So let's see if this beeps. Okay, so here's the pressure switch, right? So that means current is going to flow to one leg of the coil. Okay, now let's look at the other circuitry, and that's power in, goes to the oil low, God, I keep saying oil pressure, oil level, and then it comes out of this heater and it goes to here. Okay, so we have two legs, two separate circuits, if you will, that are closed. So when power is applied here, it's going to go all through there, energize the coil, and then it's going to close this contactor, bam, send power out here and go to the motor. So this thing will fire. I mean, we just tested it. So that's that. All right, it's all wired up, so we're ready to flip the breaker and see if it works. Basically what I got here is a 50 amp plug, and here's my welding extension cord, and this is just temporary, just to test, right? So I got 2 hots and a ground. So this here, L1, L2, is your 2 hots coming in, and then I just have the grounds tied together right here. Okay, so we got power coming in, and then I made a little whip for the motor. So I got black and red, 2 hots and a ground going. And then over here in the box, you hook up 1 hot to here, another hot to here, and the ground. And this motor can rotate either way. There's a little sticker here, tells you how to do it. If you want to flip the rotation, you flip T8 and T5 wires. So I actually had to flip it. So T5 and T8 were, black and red respectively, and then I flipped it black red. Okay, so you just flip the 2 wires. So this is all hooked up, and now we can test it out. All right, here we go. Tons of air. Oh my God. All right, so that was with the pump output just blowing in the wind here. The aftercooler is not hooked up. It's not pumping up the tank. This was just a test run. It rotates the correct way. It powers up. Everything's cool. Air is coming out of the exhaust of the motor pump really well. And I spun this off. It sucks like a mother through this intake, which is good because on my old compressor, when the pump was shot, air was going in and out. So there was blow by. You want this thing only sucking, and it was sucking like crazy. So far so good. What we're gonna do is flip this around and put the aftercooler on and all that. I think it's ready to go. So that's awesome. Okay, so this is all back together. I was able to tweak all this back to where it was. Mainly this guy, this bracket, they laid it down, so it tweaked it in. I was able to bash it back into place. This belt guard you can bend with your hand. The copper tube is pretty easy to bend. So what I'll do is I'll turn it on and try to pump it up, and I'll spray all these joints, make sure there's no leaks, and then we'll see how it builds pressure. Okay, so what we're going to do is we're going to turn it on and let it pump up 0 to full pressure and just see how it goes. I got an amp clamp on there just to monitor the amperage for the motor. I'll probably have to adjust the heater on here, starter, whatever. But anyway, I just want to calculate the CFM. So it kicked off at 125. That's fine. So I'm going to do the math really quick. All right, guys, so I had to adjust the heater. It was set at 24 amps, so obviously this thing tripped early. I turned it up to 36 amps. The motor plate, nameplate says 36 amps FLA, and then I had my amp clamp meter on here, and all the way up to 170 PSI, it pulls 32 amps. So now I got a little safety in here, 4 amps. So overall, it runs great. It recovers from 135 to 175 in a minute, and it pumps out 23, 24 CFM. So it's really, it's a ton of air, man. So it's really nice. So anyway, it's all done. I'll put the cover on here, and obviously put the cover on here, and I'll put a whip to the whatever, but this is all just temporary. But man, I'm really happy with it. It works great. Okay, so now at this point, a couple months ago, I had 2 compressors, the 7.5 horse single phase and the single phase 5 horse, both 80-gallon units. And my thought was, hey, at this new house, why don't I sell both these compressors and then put like a rotary screw in the basement? It'll be quiet. It'll give me more garage space. It'll be closer to the main panel, so maybe I don't have to freaking run 220 all the way out here or whatever, and then I can just simply run the air line out here, right? Well, moved all our stuff in, and that utility room basement area got jam-packed, and then I'm like, how am I gonna get a 600-700 pound freaking compressor down in the basement? That's not gonna happen. I can barely move a damn couch into this house without hurting my back or whatever, you know. So anyway, I was like, dude, that ain't gonna work. So I ended up, and I had both of them for sale at one point. So what I ended up doing is selling the 5 horse, and I'm keeping the 7.5 horse, because why not? That seemed like the best option. So it's behind me here. This is a false closet wall, pegboard wall thing that I'll give you a closer look and show you. But right now I have no way to power it. What I might do is get a bunch of extension cords and just run it to the basement, to the main panel, you know, put an outlet there and just plug it in when I need it. Not ideal, but I don't know what the heck I'm gonna do out here. I wanna get a sub panel out here at some point, but that's gonna take some time and money. Wire is just ridiculously expensive right now. All right, so this is 2x4 walls fastened at a 90-degree angle. It's not attached to the wall, it just slides away. Lined it with pegboard, so at least I can use this as storage. But here, let's go up here. So you see the compressor just lives in there. You know, I put a brace here, a metal bracket here, but that's it. It's just a 2x4 constructed thing to house the compressor and add tool storage at the same time. 2x4s is overkill. If I were to do it again, it'd probably be 2x3s. But yeah, and then I just move it out of the way when I need to change the oil or drain it or whatever. So this is the compressor I'm sticking with. It's a really nice unit. And as far as powering it up, see, I got this extension cord welding for my welder. Well, if I just get a bunch of these and run it to the basement, I could just power it up that way for when I do need it. Pain in the ass, I know, but that's probably what I'll do. So anyway, I hope you enjoyed this video. Thanks for watching.